Hello there, today we have a pretty tough one, number 133, find the median of two sorted arrays. This is a pretty difficult problem because we're trying to do find the median of two sorted arrays, but we're trying to do it in O log n plus n time, and that's going to be more difficult than like than just adding the two arrays together and merging them. So here we have nums1 and nums2, and we merge them together to get this particular array, 1, 2, 3, 3, 4, 5, and the medium is going to be 3 because we take it's even, and so we take m1, m plus n plus 1, and we get the medium of 3. Otherwise, it's odd, and we just get m plus 1, and the mid plus 1 to get the median, which is 3. The thing is, if we're not going to how do you say, merge them together, creating a O of n plus m time, what we can do is search for the correct left half and the right half of all numbers to get the median. So we just need to get well, we make sure that the left half of the numbers and the right half of these numbers, let's say this is the left half, this is the right half, and we need to make sure that the mid plus 1 and the left half of mid, this is mid and mid plus 1, we need to make sure that these numbers do not overlap, and we can simulate merging the two, if you know what I mean. So basically what I mean is, basically we can grab the first half of the characters here and the second half of the characters here. This is the left half, this is the right half, and half of these numbers is 3. So whatever it is, I'm going to grab 3 numbers, which is these 3 numbers. We just need to get 3 numbers on the left side and 3 numbers on the right side. In the same way, we do the same here. We get 3 numbers on the left side and 3 numbers on the right side. That leaves the medium number to m plus 1. And that's how we are going to do this. Let's say there are many numbers, right? One more example, just to bring the point home, is that let's say we have many numbers, 5, 6, 7, 8, right? And there are many numbers on this side and fewer numbers on this side. What is half of all these numbers? Well, there are a total of let's say 11 numbers. 11 divided by 2 is 5. So this is going to be our 5th number. 5, 6, 7, 8. Our 5th number in between 0, 1, 2, 3, 4, 5. This is going to be a 4, right? That's our mid right there. And how do we get that? Well, it's pretty self-explanatory. We try to get half of this one, and half of all these numbers is going to be a 4, but we're missing 2 other numbers, and we'll grab these 2 from here, and perfect. We found our medium, and that's how we get a total of I think 5 numbers. So this is 4 numbers plus 5 numbers, and we add them together, and yeah, and we basically have 1, 2, 3, 3, 4, which is this part here, and we're looking for that m plus 1, which exists in existence, and right there, and we just grab that. Perfect. That's all for this particular problem. Remember, it's breaking down, getting left correct half and the right correct half by splitting the half of these numbers between these 2 arrays. And so let's get started. So let's say I've made changes to the problem here. I switched these from num1 and num2 to A and B for brevity, as seen in Neetcode's video. So this is gonna be pretty similar, but hopefully the language is a little bit more clean. That way we can tell exactly what's going on here. So this is the total length, and this is half the length. And now we're gonna make sure that array A is going to be is shorter than array B, because we need half the items, and we need to make sure we're getting it from the longer half when A is empty. Okay, so let's do that. With that, we can get started with our left and right. Get the midpoint, doing binary search. So while true, we set I equal to the mid. And j equals the half, the rest. And with that, A, the mid left side, is going to be equal to A of I if I is greater than or equal to 0 within bounds, else float negative inf. A mid right is going to be I plus 1 if I plus 1 is less than the length of A, else float inf. Then we have a B mid left, which is equal to B of I if I is if j is greater than or equal to 0, else float negative inf. B mid right is equal to B of j plus 1 if j plus 1 is less than the length of A. Else float inf. The reason why we're using these as an out of bounds procedure, out of bounds, is because once we're out of bounds, we don't need to count those anymore. Okay, so let's check if the partition is correct. We just need to make sure that the 8 mid left is less than the B mid right, and the B mid left is less than the A mid right, because we want to make sure for sure that that we are getting the correct midpoints, as long as if this one is less, if mid left is less than mid right, that means that we don't have any items on the left half that's greater than the right half, and the same with A, B mid left, and all the items on the left side is less than the items on the right side, which is A mid right. We know for sure that A mid left is less than right, and A mid left is less than right. A mid right. We just need to make sure that A mid left is less than B mid right, and B mid left is less than A mid right. Okay, so if odd, which is total #2, the percentage 2, return the minimum of the right mid right, and B mid right, which is basically mid plus 1. And else even, then we're going to return the max of A mid left and B mid left, and then plus the min of A mid right and B mid right. The reason why we're looking for the min and the max of A mid left, because if we did mid left, this is the one we're grabbing, and min, where this is the one we're grabbing, because we want to make sure that we are grabbing the items closest to the center. Yeah. So, and then after that, we divide it by 2, and that's what we return. Else, that means that A mid left is greater than B mid right. That means that the items on the left side, there's too many items on the left side, and we need to reduce that. So R equals I minus 1. Else if, sorry. Otherwise, else if B mid left is greater than A mid right, that means we have way too many items in our A array, and so we need to reduce the number of items by I. To move it forward and shrink that the number of items in our A array. And with that, we are good to go. Oh, right. Test code is no good. Let's just set it 1, 2, 3 and run the code. Out of range. Let's check out what that's about. This is quite a typo. Let's run it. All right, inf again. Something's wrong, and yeah, I'm trying to figure out what went wrong here. Let's see. Why would it return inf? It should never be inf. The answer should be 2. Maybe we found a bug. Yeah, that is really strange. Oh, it is wrong. Okay. Let's see. Aha. So I think this is the error here, but that doesn't make sense. I'm pretty sure that this computes before. Let's run the code again. I'm sure I didn't make any mistakes according to my old code. Let's see. Ah, I see. There we go. That was the mistake, the B. Okay, it looks like we've resolved that issue at the end. Sorry it took this long, but that is what happens with typos. And let's get back to the lesson here. The lesson here is that we have to get the correct left half and the correct right half for all numbers. And so we split the numbers between the arrays that we're trying to get, half of them. And that's what we're trying to do. And this is how we did it. The code is very tough. I think it is so hard. I think with more practice, I think we will be able to do this more efficiently and be able to do it with less error. But currently, I think the next step is we're gonna change these. Even though this is very brief, length A and length B, the array A, array B. Because of the brevity, it's very difficult to find the error when made. So I think maybe there's something we can do about that. Maybe array A or array B. Even though it's a little, it's definitely longer, but I think with that, I think it's less likely that we'll make a typo. Maybe. We'll see. Okay. Well, if you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.